So for page 4 of your interactive notebook, please label it Arithmetic Sequences. And then you'll cut out your foldable, fold it, and then cut it at the dotted lines here. So we have arithmetic sequences, we'll talk about the explicit formula, and we'll talk about the recursive formula. So under the explicit formula and recursive formula, if you'll go ahead and write down these formulas, these are the two that we talked about in class. This one would represent your y equals mx plus b, where y gets replaced with a sub n, b gets replaced with a sub 0, d replaces m, and n replaces x. Then we also talked about another way of writing it based on what the textbook uses for the formula is a sub n equals, instead of doing the 0th term, which would be considered your y-intercept in the y equals mx plus b, we'll do the first term that you see in the sequence plus d parenthesis n minus 1. Since you shifted over 1, you have to subtract 1, so that since you're starting with the first term of the sequence rather than the 0th term. For your recursive formula, this is the one that's based on previous terms in the sequence. So we have the next term in the sequence, which is represented by a sub n, is equal to the previous term in the sequence, which is represented by a sub n minus 1, plus whatever your common difference is that we use as d. This formula is not usable at all if you don't give me at least one term in the sequence. So it doesn't matter if it's a sub 1, it could be a sub 0, a sub 2, a sub 3. As long as you give it one term of the sequence, you can start creating this formula. Typically, they'll go ahead and give you either a sub 0, a sub 1. If you will, open up the first tab, please, that says Arithmetic Sequences. All right, so the definition of arithmetic sequence is a sequence where the difference between any two consecutive terms is constant. This should sound familiar. We did this when we were talking about linear functions and figuring out if there was a common number that you either add or subtract every single time. This common number that you add or subtract by is called the common difference, and we represent it, use the letter D to represent it. This would be like our m in y equals mx plus b. Here's an example. We have 35, 32, 29, 26, and so forth. This is an ellipses, these dot, dot, dots, and it means it continues on that same exact pattern. So a sub 1 would be represented by 35, a sub 2 by 32, a sub 3 by 29, and so forth. So you can notice from 35 to 32, 32 to 29, if I were to subtract these numbers, every single one of them would be subtracting 3, or you would get a negative 3. So therefore, 35 minus 3 is 32, 32 minus 3 is 29, and so forth. That means we have D, our common difference, being negative 3. If you'll open up the next tab, please, we'll start talking about the explicit formula and using that. In this formula, a sub n represents the rule that you're using to generate the terms of the sequence. So this will be whatever formula that we plug into to create the next term of the sequence. A sub n equals a sub 0 plus dn. Remember I said that this can be thought of like y equals mx plus b when you're looking at linear functions. So the example asks you to write the explicit formula for the given sequence. You're going to need to know your value for d and your value for a sub 0, or your value for d and your value for a sub 1. Remember, there are two different equations that we could use. So the first thing, I'm going to try to figure out what d is. That's easy to do. In this case, you're subtracting 4 from each term to get the next one. And then a sub 1 is equal to 80 because it's the first term of the sequence. So if I use the textbook formula, I end up with a sub n equal to a sub 1, which is 80, plus d, which is negative 4, parentheses n minus 1. If I use the one that we're used to, being represented by y equals mx plus b, I have to go back a term, what would be considered my y-intercept, a sub 0. So if I go back, I'm going to add 4 and get 84 as a sub 0. And therefore, we now have a sub n equal to 84 minus 4n. This would be like your y equals mx plus b form. And then for the last tab, we're talking about your recursive formula now. So in your recursive formula, a sub n represents the next term of the sequence. It's equal to a sub n minus 1, which is represented by the previous term, and then plus your common difference. Remember, a sub 1 being the first term in the sequence, you could either give me that or any other term so that I can actually generate these sequence. And that's what this is saying, that you have to be given at least one term, or else the formula can't be used. So in this example, we want to write the recursive formula for this sequence. So again, we need the value for d in either a sub 0 or a sub 1. Since it's the same sequence we've already used, we know our value for d was -4. So we have this formula that we can use, which is a sub n is equal to a sub n minus 1 minus 4. I can say that a sub 1 is equal to 80 so that I can actually generate this. Or I can use a sub n equals a sub n minus 1 minus 4, the exact same one, and I can instead give you a sub 0 equals 84. It actually doesn't matter which of these you use. And that's all for this page.